Okay, today we are going to discuss about metallurgy. What is meant by metallurgy? Metallurgy means extraction of metal from its ore. From its ore. What is meant by ore? Ore means we have combined form of metal. Actually, if you take copper and iron, aluminum, all these are present in earth crust. In earth crust, not in individual form. Aluminium does not does not present like as aluminium. Aluminium is present by combining with any another element. This is called as combined state. This is called as combined state. Now, here two types of combined states are there. One is a mineral, another one is ore. What is meant? This is also combined form of the elements. Combined form of elements. So for example, we can take as Fe2O3 or Al2O3. All these are combined form. Both are combined form only. Mineral and ore. But what is here? Ore is a metal percentage is more. Metal percentage is more. Means it is having profitable percentage of metal economically. If we want to extract the metal, if metal percentage is less in minerals, metal percentage is less. How can you extract? What is the use for that? If you are extracting only 2% from its mineral, only metal is 2%. If you want to extract 2% of metal, is it useful? It is a long process. By doing the long process, you are getting only little amount of metal. What is the use of that? So there is no any use. So that we are taking from ore. Ore means it is having the profitable percentage of metal. So metal percentage will be more in this ore. So that we are extracting the metals from its ore, not from the minerals. Not from minerals. Now, I hope you can you understand what is ore and minerals. What is ore and minerals? Now, it is in combined form. In ore, metal is in combined form. How can we extract the metal? By using some chemical process will be there. What is that? Chemical process. First we are taking ore. Any ore you can take. By using this process only we need to separate it. Ore is present in earth crust. So you need to remove the impurities. So many impurities will be there in that. So you have to remove the impurities first. So what is that is called as, what is that? Concentration of ore. Here impurities will be there because they are present in the earth crust. So that we need to remove that impurities. These impurities we can call as gangue particles. Gangue particles means nothing but impurities. So we need to remove that impurities to get the concentrate ore. So this process we are calling as concentration of ore. So by removing the, what is the process we are doing? Removal of gangue particles. Removal of gangue particles we are doing in first process. In this process, this is the first process. In first process, we are removing the gangue particles. So we will get concentrated ore. Now you got the concentrated ore. After that what we need to do? Ore has to convert as a metal oxide. Ore you need to convert as a metal oxide. Means in this ore, either aluminum, zinc or iron, copper, any metal it may be present in this ore. that oxide you need to, if you take for example aluminum is there, aluminum oxide, you need to convert this aluminum to its oxide. Already it is oxide, no need to convert. If already it is oxide, no need to convert. Or otherwise, if for example zinc is present as zinc sulfide, it is not oxide, you need to convert as oxide by using some process. What is that process? This is part 2. This is part 2. After that, by using some methods, metal oxide, you need to do the reduction. Why reduction? What did you call as a reduction? Reduction means now metal oxide is there with you. Metal plus oxygen, metal oxide is there with you. Now, if you want to do reduction, reduction means what ma? Removal of oxygen. Reduction, removal of oxygen is called. Addition of hydrogen, addition of hydrogen. We don't want to do addition of hydrogen now. Removal of oxygen, you will get metal. You will get metal by using reduction. By using reduction. So, in part 3, we are doing the reduction to get the metal. What is this metal? By using all these process, process 1, 2, 3, so many processes are there. We are using the heat, we are adding some particles. So all these methods we will get not a pure metal here, it is crude metal, means impurities are present. Impurities are present. Impurities. These impurities, this crude metal, what we need to do? Purify. So that is called as fourth process, purification. Purification we need to do. Whose purification? Purification of crude metal, then you will get pure metal. Pure metal. This is the process. Whatever, wherever, whatever ore you can take, all the process is this only. So in this, the overall lesson is this only. That's all the lesson. But what is the topics are there? What are the methods to use the concentrate the ore? What are the methods we are using to convert concentrate ore to metal oxide? What are the methods to reduce the metal oxide to metal? What are the purification techniques to get pure metal from crude metal? This is the process we need to know in this lesson. One, concentrate the ore. Concentrate the ore. Right. What is going to happen? We need to concentrate, means removal of gangue particles. Removal of gangue particles. Gangue particles means we already discussed, that is nothing but impurities. Right. Number 1, hydration. Or otherwise, hydrolytic wash, hydration or hydrolytic wash or gravity separation, all these are the names. Gravity separation. What we are doing? We are taking a ore powder and continuously ore powder continuously wash with water. Continuously wash with water, which are having the less density. They are floats on the water and they wash with the, they wash out by the water. They wash out by the water. This is called as hydrolytic wash. Means we are washing with the water not only one time, two time, more times, repeated times we are doing. We are doing the wash with water to the ore powder. Which gangue particles are less density, they are washed out by the water. After that, froth flotation. Froth flotation. Froth flotation. What is meant by froth flotation means here we are using pine oil. Pine oil. We are adding the pine oil to the ore powder and water also, and continuously rotating the ore, continuously rotating the ore powder with water, and we will get froth on the mixture, and impurities will be separate. Impurities separate by froth. What we need to do? We have to take the ore powder in this. To ore powder we need to add pine oil, and by dipping in the water continuously movement takes place, means by using a pedal we need to continuous rotation will be there in water and ore powder. Due to the continuous rotation we will get the froth. Along with the froth the impurities will be go out, and this froth flotation is only for sulfide ore. This you need to remember. It is not suitable for all the ores. For example, Al2O3 is there. You should not do this one. Al2S3, aluminum sulfide is there. We can do. ZnO we cannot do. ZnS, yes, we can do. ZnCO3 we cannot do, because all these are not containing the sulfur. With that we cannot do this froth flotation. Which containing the sulfur, in that we can do this froth flotation. After that, third one, magnetic separation. What is meant by magnetic separation? We are taking ore powder here, ore powder here. Two jars will be there. One is containing with magnet. In this, the metal which is attracting towards the metal, that ore only we can use by we can separate the impurities from that ore. We are pouring the ore powder and coming like this. The ore, for example, iron is there. Iron easily can attract towards the magnet. So, iron particles go out in this jar, impurities will go out in this jar. So, what is the method? Why we are using this method? To separate the impurities. So, we can separate. Which type of metal ores we can use this one? Which are attracted towards to the magnet. That is the magnetic separation. And last separation is a leaching process. Fourth process is a leaching process. This leaching process is a chemical process. Till now we didn't use any chemical process in these three. It is a chemical process. By adding some chemical like as NaOH and any another chemical, by using, we are separating the impurities. That process is, for example, bauxite, Al2O3, we are separating the impurities by leaching process. In this, which of the following we are using to separate the impurities by leaching process is Al2O3. Only few ores only we are doing by leaching process by adding the chemicals. It is a chemical separation. This is the way we are concentrating the ore by remove the gangue particles. 4 methods are there: hydrolytic wash, froth flotation, magnetic separation and leaching process. After that, second process. What is the second process? We need to convert ore to metal oxide. Ore to metal oxide. Right, ore to metal oxide. In this ore to metal oxide, what we are doing actually, here three processes are there. What is that is, we know that what is that, activity series. Activity series. What is that activity series? Metal activity series. For example, sodium, potassium, magnesium, calcium, iron, zinc, aluminum, iron, this type of iron, aluminum. After that, hydrogen, copper, mercury. This series is called as activity series, means which we are going to left to right, the activity nature, reactivity nature will be decreases. So this reactivity is, this series is called as activity series of the metals. In this first metals, if you take, these are very active, very reactive in nature, very reactive in nature, very reactive in nature. In these, they undergo electrolytic process. Electrolytic process. Electrolytic process. And if you take it, bottom of the, after copper we can take it, bottom of the activity series, they are less reactive. They are less reactive. So less reactive means they are what is that, less active through the to the chemical reactions, less active to the chemical reactions. Those are also having not electrolytic separation, normal process only, normal process only. Right, middle of the reactivity series, middle of reactivity series, reactivity series. In this middle of the reactivity series, what we are doing means these all. What we are doing calcination and roasting. Two processes are there. Calcination and roasting. What is meant by calcination and roasting? In these two, we are converting ore to metal oxide. For example, zinc sulfide is there. Zinc sulfide to zinc oxide. Zinc sulfide to zinc oxide. Calcination and roasting. Zinc oxide, zinc sulfur to zinc oxide. It need oxygen to convert zinc sulfide to zinc oxide. So we are giving the oxygen. On heating, the required heat to convert sulfide to oxide. So we are heating the ore. This is ore. We are heating the ore in presence of oxygen. We are heating the ore in presence of oxygen. If you take ZnCO3, ZnCO3, is it need to give the oxygen for this ore? No need, because already oxygens are there. We are just heating. It is converting as ZnO to CO2. ZnO and CO2. So, some ores we are heating in presence of oxygen, some ores we are heating in absence of oxygen. In absence of heating of ore takes place. Heating of ore is common for both. In absence of oxygen is called as, in absence of oxygen is called as calcination. In presence of oxygen, is called as roasting. That is the difference. Calcination and roasting both are takes place by heating of the ore. Presence of oxygen is called as roasting. Calcination means absence of oxygen. These two we are using to convert the ore to ore oxide. And here, which are following? Middle reactivity series also following calcination and roasting, and less reactive series also following calcination and roasting. These are lesser. These are especially sodium, potassium, magnesium. These type of elements does not involve in calcination and roasting. I hope you understand. Now we converted. First method is completed. Ore to concentrated ore. Ore completed. Concentrated ore to metal oxide also completed. Metal oxide to metal we need to get. Metal we need to get. So third process is metal oxide to metal. Metal oxide to metal. How to get? Here two processes are there. One is reduction. One is reduction. What is reduction? Metal oxide we are taking, for example, we can take as ZnO, you can take, no problem. By adding carbon, coke, this we are calling as coke, carbon monoxide also, carbon monoxide. In this, it abstracts the oxygen from zinc oxide and converted to carbon or carbon dioxide. Or carbon dioxide means it is helpful to remove the oxygen, so it is called as a reducing agent. Now reducing agent, what is meant by reducing agent? The agent which is help for reduction. Here reduction takes place by removal of oxygen, so these two are called as reducing agents. So carbon, by adding carbon or carbon monoxide as a reducing agents, we can convert metal oxide to metal, metal oxide to metal. After that, second process is by adding active metals. Active metals, right? What is meant by active metal? For example, aluminium oxide is there. Aluminium oxide is there. If you are adding iron, here in this, what is happening? Iron is more reactive than aluminium, so it can go for replacement, displacement reaction by forming Fe2O3, and aluminium is replaced by iron due to the more reactive nature of iron. Iron can replace the aluminium, so by releasing aluminium. Like this, we can get from metal oxide to, see, metal oxide to metal. It is releasing the metal. These are the two ways we can get metal oxide to metal. This is the third process. Two processes are there by adding reducing agents like as carbon and carbon monoxide, and otherwise by adding the active metals like iron. Which are active metals? Even though zinc also you can add. But mostly which method is following? This method is following. Whatever metal you are getting here, that is not a pure metal. That is which metal? Right, crude metal. Means some impurities are there, because here Fe2O3 is there, here CO2 is there. That type of impurities will be there. So we need to remove that impurities by using the purification techniques. Now by using purification techniques, we will get pure metal. By using purification techniques, we will get pure metal. So now, till now, what we completed? Crude metal. We got the crude metal. Now purification techniques. Purification techniques. I think a fourth one. In this, what are the processes are there? Number one, distillation. Purification means the distillation is one of the process, right? Second one, liquefaction. Third one, polling. Fourth one, capsulation. Capitulation. And fifth one, electrolytic purification, right? Distillation and liquefaction, these two are. Now what are there with you? Crude metal. In this crude metal, what are present? Metal is present with impurities. You need to remove the impurities. That is our aim. Distillation and liquefaction is useful. Distillation and liquefaction is useful, which is having the melting point low impurities. If the impurities are having melting point lower than metal, then we can use these two process. So like that we can get these impurities will be what is that? Liquefy, we will get the pure metal, right? Polling process. What is a polling process? Polling process means we are taking green, what is that? Logs from the plants, green logs they are taking and continuously shaking the metal and impurities mixture with these green logs, and impurities get oxidized. By taking the green logs, we are continuously stirring the metal and impurities mixture. Due to that, means here it is in liquid state. They are convert this crude metal part into the liquid state by giving a high temperature. So by continuously stirring these, due to the green logs, the impurities get oxidized. We will get only pure metal. After that, this capsulation is using for to oxidize, which are oxidize the impurities easily. When we are using this process, if the impurities are easily oxidizable impurities, then only we are using this process. And electrolytic purification, regularly we are using method for the purification is electrolytic purification. In this we are taking, very important this one, in this we are taking two metal rods and connecting to the battery. One is we are calling as anode. In this anode positive charge, one is cathode negative charge. Always you need to remember cathode means reduction means loss of gain of electrons, and anode means oxidation means loss of electrons takes place. Here in one place we are taking impure metal. At anode we are taking impure metal, here we are taking pure metal. Here due to the loss of electrons, Cu plus 2, for example copper we are taking, due to the loss of electrons, Cu, this copper rod, this is impure copper rod, is converting as by loss of electrons Cu plus 2 electrons. Now Cu plus 2 ions are there. These Cu plus 2 ions attract towards to the, this takes place at anode. This Cu plus 2 attract towards to the opposite charged electrode. Here electrons will be gained. It is converting as a Cu. It is at cathode. Now what is happening? Impure metal slowly converting as ions. These ions are converting towards to the move towards to the cathode. At cathode it is converting to the copper again. Here impure copper is what is that? It is decomposing. Here slowly the weight of copper will be reduced. Here slowly the copper weight is improved, because here it is converting to Cu plus 2 and going attached to the cathode. So like this way impurities will be removed at anode itself and pure copper will be formed at cathode. Like this way we are purifying. Mostly we are using easy method is electrolytic purification. Like this way we are purifying the metals.